Namaskar friends, welcome to last but one session in our course on operations management. We are currently in the 12th week of discussion in the course and we are focusing on some of the advanced tools, advanced methods, techniques that are used for managing the operations in the best possible manner. And in that context, we are covering the materials requirement planning, and in the previous session we have seen the basic concept of materials requirement planning and how it can be used by the organizations for better management of their operations. We have seen that the materials requirement planning system works on a set of input and then it utilizes the information that it derives from the inputs to convert it into some tangible outputs which help the organization in decision making related to management of materials as well as the operations. Now we have seen in the previous session that materials requirement planning is usually dependent upon three important inputs. The first important input is the master production schedule, and in master production schedule the input is the sales forecasting or the customer's demand. So the first important input to our MRP system is the master production schedule. The other input is the inventory status file. We need to know that what is the inventory level in the organization, what is the current level of materials available, what is the quantity of materials available, how many materials are being used, how much material has been ordered to the vendors. So all that status file is required as an input for the MRP system. And the third input is the bill of materials that depends upon the final product structure. Now we have to manufacture a product which suppose has 5 different subcomponents. So bill of materials will give the number of subcomponents, which means that what is required for making the end product, as well as give us the number of individual components required for making the complete product. So if you remember in the previous session we have seen that 3 inputs are going into the MRP system and the MRP system then works on this input and tries to produce an output which is helpful for the decision making process in the organization. So based on these 3 inputs, how the system will work and what type of outputs we will derive and what will be the advantages and limitations of the MRP system, that we are going to understand in today's session. So let us begin our discussion with the concept of lead time, because it is the most important factor that governs the working of the MRP system. Now lead time is the time spent between ordering a particular component or a batch of components from till the time we receive the delivery at our organization or in our factory. So the time gap between placing an order and receiving an order is basically the lead time, and that is very important because the MRP system works on this lead time because it generates a auto trigger that the manufacturing must start on a specific date, and this input comes from the master production schedule. So once we know that manufacturing of a particular component that has to be fitted into the final product must start on this particular date, the system must know that what is the lead time for procurement of materials that are required to start the manufacturing of this component. So if we know that the lead time is 10 days, so 10 days prior to the date of manufacturing of this component, a trigger must be sent to the vendor that product is going to be manufactured. This much number of components are required by such and such date. So once these components or parts arrive, then the manufacturing can start on these components, and then these components will further become a part of our final product. So lead time is very important in case of materials requirement planning. So we will start our discussion with materials requirement planning specifically focusing on the lead time. Now lead time, first we need to understand what is lead time. It is the time needed for completing the job from the initial stage to the final stage. Now the job can be procurement of materials. So suppose we are procuring the materials, so the lead time will be the time starting from the ordering of the material to the final receipt of the material. So the ordering lead time, you can see start of purchasing process to receipt from the supplier. So the time gap between the ordering to the receipt is called as the lead time. Manufacturing lead time is usually the processing of part through the machines specified on the route sheet. So we know that there are different sequence of operations to be done on a material to convert it in from a raw material into the final product. So the manufacturing lead time is that the how much time is required to manufacture that part following the sequence of operations which have already been laid out. The most important part in MRP system is that we must know both these lead times, the ordering lead time as well as the manufacturing lead time. Now based on this lead time, how the MRP system will work. So the how MRP uses the lead time data is explained with the help of this simple diagram. Let us start from our final product. On x-axis we have time. Final product is required on maybe this 7th day. Now we must know that when the sub-assembly 1 is needed, we have to offset in this direction, and then there has to be some time gap because this sub-assembly 1 needs to be assembled to some other part or a basic structure to get our final product. So we know that when our sub-assembly 1 must be ready so that the final assembly operation may take place. Now we must know that we have to place an order for the sub-assembly 1, because for manufacturing the sub-assembly 1 or for processing the sub-assembly 1 we may take some time, or I must say we will definitely require some time to process this sub-assembly 1. So once we place the order for sub-assembly 1, we have a time gap here during which the sub-assembly 1 will be manufactured. And for manufacturing of sub-assembly 1 or for assembling of sub-assembly 1, we need the start of production which is given here, and finally we have to order the raw material which is required for sub-assembly 1. So the total overall start of production is here. Sub-assembly 1 is another part that will go into the final product. So this is just an example to explain how the lead time data will be used. So start of production to the final product, this is the manufacturing lead time, and here we can see that order of material and maybe the final delivery of material, this is the ordering lead time. So we need to understand that we have ordered the material here, it will take some time to arrive and then our production may start. So from sub-assembly 1 needed and place order for sub-assembly 1, this is showing us the manufacturing lead time, and ordering of the raw material and receipt of the raw material for starting the production is giving us an example of the ordering lead time. So we will make use of both the manufacturing lead time also as well as the ordering lead time also, and we offset from the final delivery schedule. So we have final product required on this day, so we will calculate the offset when what must happen in order to ensure the final delivery of the product. Now there can be different types of demand based on which we will produce our master production schedule. So there can be dependent demand and there can be independent demand. So that we need to understand, because based on that only our further inputs to the master production first is the master production schedule, inputs to the master production schedule, and also our inputs to the materials requirement planning system will depend upon the type of demand. So the demand basically in case of our materials requirement planning can be of two types: dependent demand, product demand related to other items, and as item is component of the other product. So the product demand related to other items as item is a component of the other product. So I think the language is slightly complicated, but maybe I can try to explain it with the help of an example. Suppose we are going, our end product or our final product is a car. So the number of cars that are required, that will be our independent demand. Independent demand means because we will use any given method of sales forecasting or demand forecasting to find out that how many number of cars are going to be sold in the next year or in the financial year 2018-19. So for a particular period of time, what is going to be the demand, that is our independent demand. But once we have finalized that independent demand, our dependent demand will be that how many steering systems are required, how many wheels are required, how many chassis are required, how many seats are required. So our independent demand is the demand of the car, but all other things that are going to go into that product will be our dependent demand, that we are going to understand with the help of a diagram also. And then the other type of demand can be the lumpy demand. The demand is sudden or in large quantity increment so as to make a batch of final product. So lumpy demand can be that it has suddenly been generated, so we have to immediately respond to that kind of demand, and our MRP system should be flexible enough to absorb that demand, do the calculations, order the materials, and finally able to satisfy that demand that is lumpy in nature, that has just arisen because of maybe some exigency or some emergency. But in most of the cases we will see that there will be a independent demand and there will be a dependent demand, and our MRP system will be easily able to absorb that demand and sort out the materials as well as the operational issues related with the demand. So let us take an example on your screen, that is independent and dependent demand. In the previous slide we have seen dependent demand. Here we can see the difference between the independent and the dependent demand. So independent demand is the final product, as I have taken an example of a car. So A is representing our car. This is independent demand. From where we will get this number from sales forecasting. We may use any method, we may use qualitative or any quantitative method of forecasting. We can use averaging method or time series forecasting model. So any method we can use to get this number A. Once we have this number A, now all other things that are required that will go into the manufacturing or assembly of A will represent our dependent demand, because once we know that so many number of cars have to be assembled, we will definitely be able to calculate that what are the other sub-parts, sub-assemblies that will be required to meet this demand. So the dependent demand into component parts is given. So B maybe in 4 numbers is required, C as 2 numbers are required. For B further we require D and E, the numbers are also given. So basically the summary is as is given on your screen. The independent demand is uncertain. So always in forecasting we have seen that many times we may not be able to forecast accurately, we may be over forecasting or under forecasting. So the independent demand is uncertain, that is for A. Whenever we are forecasting we may not be able to forecast accurately, but the dependent demand is certain. If we know how much or how many number of A products we have to make, we can certainly calculate how many B will be required, how many C will be required, or what will be the sub-components required to make the final product. So the independent demand is uncertain. There is a maybe kind of probability required, or maybe there will be some probability of focusing on the exact number, but the dependent demand we will be certain in nature because it is being calculated from the independent demand. Now this is a continuous versus lumpy demand. Our MRP system will work perfectly in case of a stable demand, but will have to be adjusted in case of a lumpy demand. Now how the MRP works, there are few terms that we must know. First term is the bucketing. Now what is bucketing? At what time and in what quantity a product is needed. So that is the answers that we try to look at. MRP starts with consolidating period requirements for different end products. These time periods are called the buckets. Add service spare parts which are not included in the MPS, that is a master production schedule. So first is the buckets, that are the time periods, as in the first sentence we have written at what time and in what quantity a product is needed. So these time MRP starts with consolidating period requirements for different end products, and these time periods are called buckets. So first is the time domain that we need to fix up, because then only we will be able to order our materials. We need to check the level of inventory available within the organization. So first thing is the time frame has to be fixed for the end products. As we have seen in the previous slide, we have tried to see the concept of lead time. Our end day has to be fixed, and then we offset all the other operations. We try to make use of the manufacturing lead time, we try to make use of the ordering lead time, but first and foremost is we need to have the time interval and the time domain fixed for each and every operation that is required to deliver the product or to manufacture the product, and these time periods are called the buckets. Then the part explosion, each item exploded into constituent materials. If you remember the previous slide, we have seen there is a product A which requires certain number of parts B, part C, then part B also further require another parts. So that is the parts explosion. We must know that in order to make the final product, what are the different types of sub-components, sub-assemblies required. Within the sub-assemblies, what are the other nuts, bolts, screws, and what are the other things required in making that sub-assembly, what are the individual parts required. So we explode the complete product into its individual sub-assemblies and further into components and parts. So each item is exploded, that is divided into the constituent materials, parts, components, etc. Then offsetting. So we know by now how the MRP will work. Time domain is fixed, the number of parts that are going to go into the final product is also fixed. Now the concept of offsetting, displacing the requirement by a period equal to the lead time of the product, and therefore I have explained this concept in the very beginning of today's session, that once the final date is fixed, we know how many parts are required using the parts explosion. Now we will offset that this is the final delivery date. Before this, sub-assembling is required by this date, final assembly will take this much time. Then for sub-assembly to be ready, this is the manufacturing lead time. Today we order the material, 10 days lead time for the receipt of the material. We will offset our ordering cycle accordingly. So we will offset our different operations in time domain so that we are able to meet our deadline of supplying our consignment or the batch of products to our customer. Aggregation, finding gross requirement for each component or raw material. So MRP will calculate, it will find out that what is the gross requirements of material. Maybe same component may be required in 5 different product lines. So it will aggregate, it will make the complete requirement, because if you remember, we have seen in our materials management there is a concept of quantity discounts. So instead of ordering the material for each product their company may like to aggregate the material requirement across the product lines and take advantage of the quantity discounts that are available with the vendor. So that is the aggregation it will do, finding gross requirements for each component or raw material. Then netting. So netting means that currently there will be some inventory stock available with the organization. So it will see that the gross requirement and the inventory level available, what is the net requirement, because some parts already we have in our inventory. Gross requirement also we know through the system. So what is the net requirement? So net requirements will be whatever is the gross requirement minus what is the inventory on hand, that is whatever is available, minus some we want to keep as the safety stock, and some inventory available with us might have been allocated to some other product lines or to some users. So we will see that what we have in hand, how much if we want to keep as a safety stock, how much we have committed to some other product lines. So whatever is already committed, safety plus whatever is available, this is one summation, and what is required is another summation. What is the difference is finally that we would like to have or that we would like to order. So this is the way the system will do the calculations and then will give a output which will be useful for the company. Now it will work out a procurement schedule. The requirement is now advanced by a lead time for final assembly. Lot sizing is done. This is used to consolidate the requirements in pre-specified lot sizes so that the economic order quantity may be ordered. So we can see that once we know the gross requirement, we can see we will make it in lot sizes so that we can take advantage of the economic order quantity. Now this is the way the system will do certain maybe calculations or maybe functional decision making, and finally it will generate a output. So lot sizing and then aggregation and gross requirements and then offsetting and all these bucketing, all this will be done, and finally our output will come in the form of primary outputs as well as the secondary outputs. In primary outputs we will get a planned order schedule which will be the final output in the terms of that we will have an idea that how much material have to be ordered and on which date, so that our final product delivery schedule is fixed, it is met, and we are able to honor the commitment that we have done to the customer. So that planned order schedule will be one output of our MRP system. Another output will be changes to the planned order. Sometimes the things may not go as per our planning. So whatever minor major modifications have been done in the planned schedule, that will also be our primary output. But apart from the primary output, we will definitely get a secondary output also, which will be the planning reports, the performance reports. The performance reports may include that what was planned, what was actually executed, what was the difference, whether that difference is acceptable, or if it is not acceptable, what are the reasons for those differences. So all that will be coming in the performance report. And then the exception report may be there, that if there is certain exceptions that have been done in the planned order schedule, why they have been done. So those reports will also be the output. Now let us see one by one the outputs that the MRP system will generate. So primary outputs, you can see planned order schedule. This is used to determine the future production and supply at suppliers and along with guide for in-house production schedule. So we will be able to get a planned order schedule as we have seen and used to determine the future production and supply at suppliers end. So we will be able to tell the supplier that at what duration of time what will be required, when we are going to order. So all that things will be available at hand on our system as an output of the MRP system, and as well as within our organization also we will be able to find fine tune or maybe decide on our production schedule. Changes in the planned order, modifications in previously planned order. As I have already told that we have a planned order, but because of certain changes or certain modifications, there may be certain changes in the planned order that will also be covered as a MRP output. Now secondary outputs are exception reports. I have already explained, I'll just read it out for you. Used to point out serious discrepancies such as late or overdue orders. Performance report will give you used to determine agreement between the actual and the programmed usage and cost. So what is the difference, or whether it is in agreement. Planning report used for future planning of inventory. So once we use the MRP system, we will get these outputs. Now what are the benefits? Let us quickly see, read the benefits. All of them are self-explanatory. Understanding the effect of changes in future periods, improved customer service, reduction in lead time, increase in productivity, reduce purchasing cost. Because if you remember, we have seen that we will do the gross aggregation of the requirement, and then we will may be able to take advantage of the quantity discounts. Reduced purchasing cost can be achieved. Improve production and supply schedules, because now it is automatic, so it is not human intervention is minimum. So as soon as the inventory level goes beyond a particular point, auto order or maybe a triggering point will be there, which will bring the order into effect. So our production and supply schedules will improve. It will reduce the manufacturing cost, because stoppages maybe because of the stock out of materials will be less, because the material procurement is now being handled automatically. Less scrap and rework, higher production quality. So we can see that if we implement the MRP system directly or indirectly, there are going to be many advantages, and these advantages will lead to overall effective and efficient management of our operations. So we can explain each one of these with the help of an example, but maybe I will leave it for readers to just look for case studies where the use of MRP system has led to improvements in the operations management of the organization. But there are certain drawbacks of the MRP system also. So this we can see that if there is inaccuracy in suppliers lead time, maybe we know that today we have placed the order, after 10 days we will get our receipt of order, but if we are not getting it in 10 days, it will certainly affect our further operations, because we have done all the offsetting calculations based on our due date of delivery to our customer. So if our supplier is not giving us the material in the agreed lead time, we will be at loss. So that can be one drawback. MRP depends heavily on correctness of lead time data, and therefore we started our discussion today with the lead time only. Then sometimes our inventory data or inventory status file may not be up to mark, and therefore if we have wrong data from the inventory status file, MRP system will not be able to work efficiently and may give us erroneous results. And similarly, inaccuracy in manufacturing lead time. We know that the route sheet is available with us. This particular product has to undergo 5 different operations, and this must require 7 days as a manufacturing lead time. But if it takes 10 days, our MRP system, whatever system we are following, may not be able to give us the desired result. So the change in the customer's demand, change in workload of factory may lead to inaccuracy in the manufacturing lead time. So there are certain drawbacks associated with MRP system also. Then the inaccuracies in the bill of material structure. Sometimes there can be change in design, component substitution without recording. So if our bill of materials file is not changing, but the product has changed, again it will lead to malfunctioning of the MRP system, because any change in the bill of materials file must definitely be accounted in the MRP system in order to get the accurate results or accurate order scheduled or the planned order schedule, which is the output of the MRP system. So finally we can conclude our discussion on MRP, as that MRP is a computerized inventory control as well as production planning system that schedules component items as needed, which will track inventory and help a company in many other aspects of business. So it is a computerized materials management system as well as helps us in the production planning also, and it will help us minimize the human intervention in the material management function of operations management. Now the conclusion can be advancements further like MRP2 and ERP have been able to link the manufacturing with other areas of business such as finance and marketing. So materials requirement planning focus much on the materials aspect or materials management aspect of operations management, but there are advanced systems which integrate the complete operations of the organization, including the finance and marketing aspects also, and such systems, enterprise-wide systems or centralized control systems are also available. And in the next session, that is the last session of the course, we will be discussing one such system, that is the enterprise resource planning or ERP system. Thank you.